and welcome back. You are with Allen High School Pre-AP Chemistry, and we are studying acids and bases and moving into our calculations involving H plus, OH minus, pH, and POH. So let's take a look at this first one. It says if the hydronium ion concentration, remember hydronium is H3O plus, concentration, we use brackets, is given as this, then it says, what is the hydroxide concentration? Well, if you look at your little square of formulas, you will remember that H3O plus or H plus, either one, will accept either, is equal to 1 times 10 to the minus 14th. So if I substitute in there 4.6 times 10 to the minus 6th times my OH minus, I get 1 times 10 to the minus 14th, and my final answer is 2.33 times 10 to the minus 9th molar. Don't forget those units. You always have to have units on our numbers like this. pH doesn't have units, but molarity does. Now the question says, is it acidic or basic? Well, our H plus or hydronium ion is greater than our OH minus, and therefore it is acidic. Okay, let's take a look at the next one. The next one gives us our concentration of hydroxide and asks for our hydrogen ion. Hydrogen ion and hydronium ion can be used interchangeably. So we're going to be using the same formula that's up here, except this time I'm going to substitute in, hopefully I will substitute it in correctly, our hydroxide concentration. 1.6 times 10 to the minus 5th, 1 times 10 to the minus 14th. It's multiplied on this side. I divide to bring it to the other side, and we find that our H plus concentration, final answer, if I did my algebra right, always check me out in case I finger slipped on that calculator, is 6.25 times 10 to the minus 10th molar. Now in this case, the H plus or hydronium is less than the OH minus. If the OH minus dominates, therefore, that's what that little triangular dots mean, it's basic. Okay, so hopefully you're getting on a roll now. Let's take a look at our next one. We have a POH, and we are asked for a pH. So you take a look at your formulas. You're better off memorizing those formulas so you can work faster. And pH plus POH is equal to 14. So pH plus 5.6 is equal to 14. So my pH is equal to 8.4. Now, since pH is greater than 7, that means that this is a basic solution. Okay. Now, if the pH of the solution is known to be 4.2, what is the hydrogen ion concentration? Well, pH is equal to minus the log of the H plus. I'm going to derive this for you one time, just so you see where we get this. I'm going to bring the negative sign over. Minus pH is equal to the log of the H plus. Now, the opposite operation, I think I did this earlier, but it bears repeating. The opposite operation of 10 to the power of log is 10 to the power. So 10 to the minus 4.2 is equal to my H plus concentration. I think you actually have that on your formula chart, but you really need to be learning some of this algebra for when you have that opportunity to take AP chemistry with me. So that's my answer, 6.3 times 10 to the minus 5th molar. Now, we know that it is acidic because the pH was less than 7. We don't need to calculate the pOH. We don't want to do extra work if we don't have to. This time it says, what is the pH? So pH related to hydronium ion is minus the log. Notice how I'm whipping back and forth between H plus and H3O plus. You need to get used to that. They're symbolic synonyms, and I want you to get a sense of what they're both like. Minus the log of 5.5 times 10 to the minus 10. And when all is said and done, my pH is 9.26. Now, since that's greater than 7, we know we have an acidic solution. All right, forging ahead. You're going to do quite a few of these in a chart in class and really get a sense of moving back and forth and making choice of directions. Now, this time we have pOH. There is, and we want H+. There is not a direct path between pOH and H+. We have two possibilities. We can go pOH to OH minus, and then OH minus to H+. Or we can go pOH to pH, and then pH to H+. I'm going to do both of them for now. I won't do that all the time, but I really do want you to see what these are like, and it actually answers the next question for us. So it worked out pretty conveniently. So I want to find first my OH. My OH minus is equal to 10 to the minus pOH. Just like H plus is 10 to the minus pH, OH minus is 10 to the minus pOH. And so if I plugged in 3.4 for pOH, I'd get 3.98 times 10 to the minus 4th molar OH minus. Now, remember that H plus times OH minus, so my H plus times my OH minus is equal to 1 times 10 to the minus 14th. And if we do that algebra, I have an H plus concentration equal to 2.5 times 10, or 5.1, times 10 to the minus 11th molar. Don't forget your units on those concentrations, okay? Now, let's do it this way. To get from pOH to pH, remember pH plus pOH is equal to 14. So pH is equal to 10.6. And then H plus is equal to 10 to the minus pH. And if you do that algebra, you'll get the same answer. Not going to write it again. Okay, so those are the two possibilities. Honestly, I tend to lean towards this second one. I feel like I'm hitting exponent keys and a few less keys that way, but that may be perception. I've really never measured it. But the next one says, what is the OH minus concentration in this problem? And because of the way we set up this problem, we actually have the OH concentration right here. So we've already done 15 because I showed you both ways to do this problem. Okay, now let's try 316, and I'll do it both ways again, and you'll see that in doing so, we will solve 317. So in 316, I have the pH is equal to 7.9. Now, I can't get directly to hydroxide concentration. That's two steps. So I could go pH to pOH, and then I can go pOH to OH minus. Or I can go pH to H plus, and then H plus to OH minus. Either path works just fine, but it's not a direct path between the P of one to the concentration of the other. I can't go from the P of one to the concentration of another, or reverse. Okay? So let's do this first one. My POH plus my pH is equal to 14. So POH is equal to 6.1. My OH minus concentration is 10 raised to the power of the negative POH. Okay? And if I solve that, I get 7.94 times 10 to the minus 7th. The little POH, pH, those are unitless. Concentration needs a unit. You don't want to lose points over something like that if we can avoid it. All right, I can go from pH to H plus because H plus is 10 to the minus pH. So that's 10 to the minus 7.9, and that's equal to 1.259 times 10 to the minus 8th molar. And then I can take that value, 1.259 times 10 to the minus 8th, multiply it by my OH minus, and remember that when we multiply these two, it's 1 times 10 to the minus 14th. Okay? And if I solve that, indeed I get the same answer, which is right here. Okay? Now the next question says, what's the hydrogen ion concentration? So the answer to 17 is actually right here. We've already calculated it because I'm showing you both ways to do these problems. So we've already done this. So you can pick and choose. Okay, that gets you a little bit of introduction to our calculations involving pH and POH. When we get back, we're going to look at some of the properties. You saw some in the movie. You're going to be doing an experiment that'll give you a good idea of what these do. So until then, my best chem students, this is signing off.